most A-level physics students get questions like this wrong. So the question is asking us, which one of these velocity time graphs match with the acceleration time graph given here? Here's what most students try to do here. They try and visualize what's happening in the example. And when you do that, it can really easily confuse you on what's actually happening. So I just want to tell you a really simple trick you can use where all you're really looking at is the slope, is the steepness of the line, or in other words, the gradient of the line. So this simply comes from recalling that in every velocity time graph, the gradient is acceleration. Now remember, when we say gradient, we just mean the slope. Okay, so let's just take this step by step. It's actually a lot easier to figure out what's happening if you just describe what's happening to the gradient of each of these graphs and then see if that matches with the description of what this graph is showing us, the acceleration time graph. So first, let's just write down what we see in the acceleration time graph in simple words. The line is increasing as time goes on. So I can just simply say acceleration increases. Now we said that the gradient is acceleration. So all we need to look for in these graphs is which one of them is showing the gradient to be increasing. So acceleration is gradient, and let's take some time to think about which one of these graphs is showing the gradient increasing. So we'll do it one at a time, just to eliminate maybe the incorrect ones first. So option C, we can see it's just a straight line. So I can quite confidently say that the gradient here is constant. So in option C, gradient is constant. Now remember, gradient is acceleration. Is acceleration constant here? Nope, it's increasing. So we know that C is incorrect. Let's try a little bit of a harder one now. So if you look at this line here, we can see the steepness is decreasing. A bit like walking up a hill, it starts off really steep and it gets less steep. So when I say steepness, I mean gradient. So the gradient is decreasing. Remember, gradient is acceleration. So really this graph is showing us that the acceleration, gradient is acceleration, the acceleration is decreasing. Okay, so it can't be B. So now we're left with A and D, and these are a little bit trickier now, but if you look at A, there's something different about the way that the gradient is shown in A compared to all the others. If you notice straight away, hopefully, that in all the other options, the line is going up, showing that the velocity is increasing. This is the only one that's showing the velocity decreasing with time. Now, just from a simple definition of acceleration, we know acceleration, as long as it's positive, means that it's speeding up. So if this line is going down, it's showing us the object is slowing down. It definitely can't be that, and I don't need to look at anything else to do with steepness here. The line is going down, which means velocity is decreasing, and that's definitely not what's happening here. It's speeding up. So we can eliminate A. Now, just from elimination, we can just see that D must be the answer, but let's just prove it and make sure we know and understand why D is the correct answer. Let's look at steepness. As time goes on, it's getting steeper, so steepness is increasing, gradient is increasing, and therefore acceleration is increasing, and exactly what we said should be happening. Acceleration increases. So D is the answer. If you want to see more breakdowns like this, follow me.